They told everyone 3I, Atlas, was just another strange object passing through our solar system. A quick visit, a short headline, then silence. But behind the scenes, scientists never stopped watching it. Tracking didn't end, data didn't close, and new references kept quietly appearing years later, which raises a disturbing question no one wants to answer out loud. What if 3I, Atlas wasn't a one-time event at all, and whatever brought it here is still happening right now? What 3I, Atlas really is? 3I, Atlas, wasn't discovered by accident. It was detected by a global alert system designed to spot objects that don't belong here. Almost immediately, scientists realized this wasn't a typical comet or asteroid drifting around the Sunday. Its speed was too extreme. Its trajectory didn't curve the way local objects do. It wasn't bound by the sun's gravity in any normal sense. That meant one thing: it came from outside our solar system. This made it only the third confirmed interstellar object humanity has ever observed, and that alone should have triggered non-stop headlines. Instead, the announcement was brief, technical, and strangely muted. Basic details were shared, but deeper explanations were left vague. No dramatic press conferences, no long breakdowns for the public, just a classification label and a quiet move forward. But inside the scientific community, interest exploded. Interstellar objects are valuable because they're untouched samples from other star systems. They carry information about environments we've never seen up close. And 3I, Atlas, wasn't just another rock flying through space. It became a reference point, a data anchor, something scientists kept circling back to, even after it was supposedly gone. And the more closely they examined where it came from and how it moved, the harder it became to explain it as just another visitor. The trajectory that didn't add up. From the moment scientists mapped 3I, Atlas's path, something felt off. Interstellar objects are expected to follow clean, predictable, hyperbolic trajectories. Fast in, fast out. No lingering. But 3I, Atlas, didn't fully cooperate with those expectations. Its entry angle was unusually steep, and early trajectory models had to be adjusted more than once as new data came in. Even stranger, its path didn't clearly trace back to any known nearby star system. That doesn't mean its origin was impossible to determine, but it did mean the margin of uncertainty was larger than usual. Some astronomers quietly noted that its approach vector passed through a relatively calm region of space, with fewer gravitational influences. In theory, that should have made its motion easier to predict. Instead, it introduced small inconsistencies that didn't fully resolve. These weren't dramatic deviations, nothing you'd notice in a headline. But in orbital mechanics, tiny mismatches matter. They suggest missing variables. And when those variables can't be easily explained by gravity alone, scientists start paying closer attention. What happened after it was gone? Publicly, the story of 3I Atlas was supposed to end once it passed beyond easy observation range. Reports stated it had exited, moved on, and effectively vanished into deep space. Case closed, except that's not how the follow-up unfolded behind the scenes. Observation logs showed that monitoring didn't stop when it should have. Certain instruments, especially infrared trackers, stayed locked on longer than expected. What caught attention were subtle readings that didn't fully match predictions made at the moment of its exit. The object appeared to experience minor changes that couldn't be confidently explained by simple gravitational drift. Not enough to spark alarm, not enough to justify a press release, but enough to keep telescope time allocated when it normally would have been reassigned. Even more telling, later summaries described its behavior in carefully neutral language. Phrases like data refinement ongoing and extended analysis recommended began appearing quietly in technical contexts. To the public, nothing was happening. To researchers, the file was still open. Because once an object is gone but the questions remain, the story isn't actually over. Why scientists kept watching? Inside the scientific community, 3I, Atlas quietly shifted categories. It was no longer treated as a routine observation, but it wasn't labeled as a threat either. Instead, it became what some researchers describe as a high-interest anomaly, the kind of object that doesn't trigger alarms but never fully leaves the conversation. Data related to it was revisited, recalculated, and referenced long after public attention moved on. What stood out most was how carefully information was handled. Updates were technical, stripped of speculation, and often delayed. Full datasets weren't rushed out the way they usually are with confirmed interstellar objects. Instead, summaries appeared first, with deeper analysis pushed further down the line. That kind of pacing usually signals uncertainty, not indifference. In internal discussions and academic settings, 3I, Atlas, began appearing alongside a small group of other objects that shared one thing in common: behavior that didn't neatly fit existing models. Not dramatic enough to rewrite textbooks, but persistent enough to resist simple explanations. And once an object earns that reputation, it doesn't get ignored. Because when scientists keep watching something long after it's supposed to be gone, it usually means they're waiting for the next piece of the puzzle to surface. The uncomfortable comparison: as researchers revisited 3I, Atlas, one comparison kept coming up quietly, even if no one wanted to center it publicly. The comparison to earlier interstellar visitors that never quite behaved the way they were supposed to. Objects that followed the math just enough to pass initial checks, but not enough to feel settled. 3I, Atlas, began joining that short list. Its physical signals didn't line up cleanly with classic comet behavior. There was no strong, obvious outgassing pattern that could fully explain certain motion adjustments. Dust signatures were faint and inconsistent. Not wrong, just incomplete. The kind of data that forces scientists to add footnotes instead of conclusions. That's where things got uncomfortable. Because once multiple interstellar objects start sharing unexplained traits, it stops looking like coincidence. It starts looking like a category we don't fully understand yet: the quiet shift in recent years. In the years after its discovery, 3I, Atlas, didn't disappear from scientific literature. It just stopped being front and center. Instead, it began showing up in broader discussions about interstellar traffic as a whole. Papers started referencing recurring anomalies and persistent interstellar characteristics, often without naming objects directly. But the timing and parameters matched. Some researchers began suggesting that objects like 3I, Atlas, might not be rare at all. They might simply be hard to detect. Current survey systems are optimized for threats and predictable motion, not subtle visitors moving fast and leaving quietly. If that's true, then 3I, Atlas, wasn't special because it existed. It was special because it was noticed. What this means right now: if interstellar objects pass through our solar system more frequently than we thought, then something important changes. Our neighborhood isn't static. It's being intersected, sampled, and crossed more often than older models assumed. 3I, Atlas, may have been part of a steady background process rather than a rare event. That would explain the continued monitoring, the cautious language, the reluctance to close the file completely. Because if this wasn't a one-off, then every new detection becomes more than an isolated discovery. It becomes a data point in an ongoing pattern, the story that never ended. 3I, Atlas, was introduced to the public as a brief encounter, a strange object from far away that passed through and vanished. But the behavior, the follow-up, and the continued scientific attention tell a different story. One where the object didn't just leave behind data, but unanswered questions. Whatever brought 3I Atlas into our solar system may still be bringing others, quietly, repeatedly. And if that's the case, then this wasn't the end of the story. It was the moment scientists realized they needed to keep watching the sky, not for a single object, but for what comes next.